Alright class, now we're going to take a look at the quadratic formula. This is something that is very positive to memorize. There's a little song that goes with it. I highly recommend YouTubing the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's stories that go with it, all kinds of great things. I highly recommend YouTubing some videos on quadratic formula song. You will find some funny videos. But anyway, you should memorize it. And what we're going to do now is use the quadratic formula. What we're hoping we understand is that we have ax squared plus bx plus c as our standard form for quadratic. And what we're going to do is replace the corresponding letters. The 6 is the a, the negative 5 is the b, and the negative 4 is the c. Those go into the quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. So we replace the negative b, which is going to be negative 5 because b is negative, plus or minus the square root of b squared, so it's going to be negative 5 squared minus 4 times a is 6 times c is negative 4 all over 2 times the a. Okay, so now it's all a process of simplifying, and if you can plug in and simplify, the quadratic formula will serve you well. But the biggest problems I have with students is right here. We don't multiply that out correctly. What we need to recognize is that that is negative 4 times 6 times another negative 4. Okay, so as you're working that out, make sure that you first of all see the negative times a negative will turn positive. So this is going to turn into a positive. Now you just have to multiply out what 4 times 6 times 4 is. Should give you positive 96. And then in front of that we have negative 5 squared. The other big mistake I have with students is they'll square the 5 and they'll leave it negative 25. And that needs to turn into positive 25. So underneath the square root, if I was to rewrite this, first of all let's change the negatives in front. If I was to rewrite this, I'd get 5 plus or minus the square root of 25 plus 96 all over 2 times 6, which is 12. Okay, so now, further simplifying, if I add the 25 to the 96, I should get 121. So this turns into 5 plus or minus the square root of 121 all over 12. And we can further simplify by actually taking the square root of the 121, which should give you 11. So we have 5 plus or minus 11 over 12. And that's still not your final answer because you want to get the actual two numbers if possible. It really needs to break up into 5 plus 11 over 12 and 5 minus 11 over 12. So let me erase some stuff over here and show you how that works out. So it breaks up into 5 plus 11 over 12, and your other answer is 5 minus 11 over 12. So if you work that out, 5 plus 11 should give you 16. 16 over 12 should reduce, divide the top and the bottom by 4, and that gives you 4 over 3. So that is one solution, and we have our second solution now. We have 5 minus 11, which should give us negative 6 over 12, which should give us negative 1/2. So we have two solutions, 4/3 and negative 1/2. And those are our two solutions for x. You should put equals x equals. Okay? I think the lab usually does that for you, but that is what x is equal to. So this is a full workout of solving quadratic formula for this problem. I did run out of space, but this is actually one that works out nice where you have real answers. Often we end up stopping right about here because you can't simplify after the square root. So it might actually feel better or more comfortable because you don't have to go as far. So let's try some more. Now in this problem, it's a little bit different from the first problem because it's not equal to 0. And you have to have it equal to 0 before you can use the quadratic formula. So we need to move the a to x and move the 1. So we do that by subtracting, and we'll get 4x squared minus 8x plus 1 equals 0. Now that it's equal to 0, I can plug straight in the quadratic formula. Negative b, so negative 8 plus or minus the square root of b squared, which is negative 8 squared minus 4 times a, which is 4, times c, which is 1, all over 2 times my a is 4. So that's the hard work. Now I just have to simplify. Why I say it's hard work is because we lose signs. So anyway, let's work this out, and I get, this is going to turn into positive 64. So I'll write it over here. I got 8 plus or minus the square root of 64. And then it's going to be negative 4 times 1, which is going to be negative 16, all over 2 times 4, which is going to be 8. Okay? So now let's get my 64 and 16 and subtract. Should give you 48. So I have 8 plus or minus the square root of 48 over 8. Now this time, I don't have a square root of 48, so I actually have to hockey stick and simplify the 48. So let me erase. And if I hockey stick the 48, I should divide it by 2. Should give me 24. If I divide it by 2 again, it should give me 12. Divide by 2, I should get 6, 2, and 3. So what that means is I can pull out 2 sets of 2's outside of the square root. In other words, it's going to be 2 times 2, and inside the square root is going to be 3. So this is going to be 4 root 3, so I'll replace that with my 48. So it rewrites to be 8 plus or minus 4 root 3, all over 8. Okay? And this would be my final answer if I didn't have a Cool Ranch Dorito problem. And it's Cool Ranch because it's blue. So what that means is that the 8, the 4, and the 8 all have a common factor. So I need to actually divide them all by the common factor, which just so happens to be 4, which will give me 2 plus or minus 1 root 3 over 2. Okay? So it's a little bit easier because you don't have to get your 2 separate answers, but you do have to pay attention for Dorito problems and reducing all 3 numbers by a common factor. Now please never look at the root and think that you can reduce there. It's only the number on the outside of the root that you can include in your triangle or Dorito problem. Okay? There is still 2 answers here. It's 2 plus root 3 over 2 and 2 minus root 3 over 2, but we can write it as one answer. In the lab, you might have to write them separately. If you did write them separately, it would just be 2 plus root 3 over 2, comma, 2 minus root 3 over 2. That's the only difference. Okay? So, now we're going to solve something like this using the quadratic formula. And in order to do that, you'll have to look for that in part 2.